In this problem, a mass of 31.77 kilograms, 31.77 kilograms, is attached to a light string that is wrapped around a cylindrical spool of radius 10 centimeters, and a moment of inertia of 4 kilograms times meter squared. The spool is suspended from the ceiling and the mass is then released from rest a distance 5.70 meters above the floor. So we're being asked, how long does it take to reach the floor? So basically, what's the time in seconds? The first thing we can do is try to find the mass of the other object, because we do know the mass that is wrapped to the spring, but we want to know the mass of the cylindrical spool. So we can actually do that by using the equation of inertia over here. The inertia is equal to half of the mass times the radius squared. And we have all these other values. So we know that the inertia is 4 kilograms times meter squared. And this is equal to half the mass. And we know that the radius is 10 centimeters. So let's convert this real quick to kilograms, 0.01 squared. And this is gonna give us, 0.1 squared. This is going to give us, once we shift it around, we're gonna have 4 equal to 0.05 times the mass, and then when we divide both sides by the 0.05, we're left with a mass of 800 kilograms. So that's the other mass that we're gonna be working with. And now the other value that we do need to find is the acceleration in this case. So now we know that the other mass is 800 kilograms, but we need to know the acceleration of the whole system. So the acceleration is going to be equal to the mass times g over the mass plus the inertia over the radius squared. And then once you plug in these values, since we're trying to find the mass of the object that is let loose, so the object with the 31.77 kilogram weight, we're going to plug in those values. 31.77 times the force of gravity, 9.8, over 31.77 again for the mass, and then the moment of inertia is 4, and then our radius is 0.1 squared. And after plugging in all these values into the calculator, we get 0.72 meters per second squared. That's the acceleration of our system. So now we're going to try to find the time with an equation of distance. So the distance is equal to the acceleration times time squared over 2. And now we can simply just plug in the values that we just found. So we know that the distance is 5.7 meters when the object hits the floor. We know that our acceleration is now 0.72 meters per second squared. And then we're trying to find the time, so we'll leave that variable alone, over 2. And now we can simplify this. After we multiply both sides by 2, it's 11.4 meters over here. And that's equal to 0.72 times t squared. And now t squared is going to be equal to, once we divide both sides, it's going to be equal to 15.2. And once we square root this value, 15.2, in order to get t by itself, we find that t is closest to 3.89 seconds. So from all these values, the closest one would be 3.83 seconds, B.